Okay, so review for test number 4. Okay, there's going to be a lot of calculator work on this test. Okay, the first problem is y equals 1/5 to the x power. Okay, so this is going to be an exponential graph, and this is something, again, you can just simply put that in your y equals, right? So if you go to your y equals and simply just type in what that function is saying with the 1/5 in parentheses, the x in your exponent, and graph it, that will show you the shape of the graph. The fact that it okay, when you have an exponent, when your x is in the exponent, it's going to make that exponential shape. But when what your base is, if the absolute value of this is less than 1, it flips this original exponential shape across the y-axis. So that's why this one's exponential shape looks like that, which would be A. All right, on number 2. 2 and 3 are both having to do with horizontal and vertical shifts of these exponential graphs. So remember, when you're talking about shifting, the inside numbers, which are going to be the numbers that are inside the exponent right now, shift you horizontally, but you go opposite the sign. The numbers outside are going to shift you up and down, and you go with the sign. So on number 2, you have f of x equals 2 to the x minus 3. Okay, which means you're going to start off with the base of 2 to the x power. This minus 3 is an inside number, right? It's inside the exponent, which means it's going to shift it horizontally, left or right, but you go opposite of the sign. So this right here, since it's a minus 3, I'm going to shift it to the right 3. Now, when you go in to do this graph, and you tell it, you know, remember how you're going to just tell it to graph the exponential function, which will put that exponential shape right in the middle of your graph. Then you're going to tell it to horizontally shift it to the right 3. Now, remember, down at the bottom of that box where you do all the shifting, there is this box right here. And a lot of times, it's going to default and put the base as E in that. You will have to delete this and put your base as 2, right? You want to use the base 2, not the base E. So make sure you do that on those graphs. Change the base to what you want it to be. Right, number 3. F of x equals 2 to the x plus 5. And then minus 1. So this one has an inside and an outside number. So you're going to start off with the base of 2 to the x. Plus 5 is your inside number. So it's going to be a horizontal shift, but you go opposite the sign. So you're going to go left 5. Here's where your outside numbers are. So that's a minus 1. So it shifts it vertically. So this one's going to shift. You go with the sign. So you're going to go down 1. And remember, before you hit submit, make sure you change the base from E to 2. Right? It's going to just probably default and set your base at E. Okay, and this will be in that box where you do the shifting. All right, 4 and 5. This is where we started talking about where we had that formula. Here's the formula formula that you're going to use for number 4 and 5. Okay, so there's what all the information in that formula means. The answer will be the A of t. That's going to be your end result, how much you're going to have at the end. Okay, the P is going to be the principal. That's going to be how much money you're going to start with. The rate is going to be the interest rate, but we always change that into the decimal form instead of the percent form. The N, which goes in 2 places, is the number of times it's compounded a year. So you're going to have to watch in this for words like quarterly or biannually. Quarterly means it would be compounded 4 times a year. So your N would be 4. If it says biannually, it'd be compounded 2 times a year. So your N would be 2. And the T is the number of years for the investment. So we're going to use this for problems 4 and 5. So on number 4, suppose that $69,000 is invested at 6.5% compounded quarterly. Okay, so let's see, A of t. Let's come up with, the first thing you're going to do is come up with the function, the function that you're going to use for the rest of the problem. So this right here, what's going to be my principal? What was my original amount that I invested? That's the $69,000. 1 plus your interest rate. Your interest rate was 6.5%, which is saying 6.5%. You're going to have to change that to a decimal, which means move this 2 places to the left, fill in your blank spot with a 0. So I have 0.065 over. Now, let's see, what's going to be the denominator of that fraction? The number of times it's compounded. Well, it says it's compounded quarterly, which means 4 times a year. So that's going to be a 4. And up here will be a 4. The T is what's going to change depending on how long the money has been invested. Now, it wants you to figure out what is inside that parenthesis when you're coming up with your formula. So you just, in your calculator, just type this. 1 plus 0.065 over 4. Okay, just like it says. 1 plus 0.065 over 4. So that's the number you're going to have in your parentheses for the formula. So 69,000 in parentheses, you have 1.01625 to the 4t. So that's the first part of your answer that you're going to put in the A spot. Right here, the function. Right here, that will go in your A spot. Now, this t, this is your variable that changes for each part of the problem. depending on how many the years are. The first one says the amount of money in the account at t equals 0 years. Okay, so I'm actually finding a of 0. What happens when your t is 0? So I'll have 69,000 times 1.01625. If I replace that t with a 0, what do you have? 4 times 0, which is 0. That's what you're going to put in your calculator and hit enter. So 69,000, open parentheses, 1.01625, close, go up into your exponent and put a 0, just like you see it on the board, and hit enter. And it's going to still be 69,000, right? Because why? Because your t was 0, which means you haven't had it in the bank any time. You just deposited it. It's not automatically going to make money the second you deposit it. So if you've had it in there 0 amount of time, you're still just at 69,000. Now, I'm not going to do every single one of these for sake of time, but it wants to know also 3 years, 7 years, and 10 years. So all you're changing for each of these times is this, right? So in 3 years, if the t was 3, what does your exponent become now? It just becomes a 12 if you replace that with a 3. So I'll do this one, and then we got to move on to the next problem to get through some more problems. So again, you're just typing in, changing your exponent to a 12. So 69,000, open parentheses, 1.01625, close. Go up into your exponent and make your exponent a 12. And you're going to round it to the nearest cent. Oh, no, excuse me, nearest dollar. Nearest dollar. So let's see. After the decimal is a 1, which means I don't need to round it up. So I'll have 83,725. Okay? So you'll just keep changing those depending on what the year is. Okay? The next problem, number 5, is another problem like this. This is the one where the girl gets some money on her birthday. So let's see, it's Melissa's 6th birthday. She gets $3,000 CD. So on 6th birthday, she gets $3,000. It earns 3% interest, compounded quarterly, and the CD matures on her 14th birthday. So let's see what we know. We don't know the end result. That's what we're going to find. Okay, so let's see. Do we know the principal? What did she start off with? $3,000. Then 1 plus. Do we know the interest rate? Well, the interest rate is 3%. So if I change this to a decimal, move the decimal 2 places to the left, it's going to be 0.03. The n is the number of times compounded a year. If it's compounded quarterly, that's going to be 4 times again. So the n goes in 2 spots. Do I know how long the money has been invested. I do on this one, right? If she got it on her 6th birthday and it matured on her 14th birthday, how long had the money been invested? Well, she got it here and it matured at the 14th birthday. She'd had it 8 years. So the T is A. I do know what the T is. So I'm actually finding A of 8. What happens after 8 years? So let's figure out what's in this parenthesis. So I have 3,000. So in your calculator, just 1 plus 0.03 over 4. One plus 0.03 over 4 gives me 1.0075. What's your exponent going to be? Well, 4 times 8 gives me 32. So when I type this in my calculator, that will tell me how much she would have had on her 14th birthday. So 3,000. Open parentheses, 1.0075, close, go up in your parentheses, 32. So here's how much money she's going to have at the end, and this time it says round to the nearest cent. So go to the cent spot and then go 1 spot after it. Since it's a 3, I don't need to round up that 3. So after the 8 years on her 14th birthday, she's going to have $3,810.33. Okay, moving on to the next ones. Says find the logarithm. Log base 10 up 10. So we can type this in our calculator. Now remember, there's a couple different ways to do it. If you have the TI-84, you can hit, and we even learned an extra shortcut, hit math, alpha, math. That gives you the log base function. Then just put the 10 in the small base area and then the other 10 in the other area and hit enter. That gives you your answer. Just 1. Now, Betsy, I know you have the 83. Remember, you can also do this even though you don't have that log base function. Anytime you are trying to find this, you would just type in log of the big number divided by log of the base number. To get your answer. Every time you can do log big number divided by log little number. All right, number 7. Same thing. Log base 4 of 4 squared. Also, you can remember, what are you doing when you're finding the logarithm? You're saying, okay, what does this 4 need to be raised to in order to be 4 squared? So you can kind of think of it like that. 4 to what power is 4 squared? Well, you have to raise 4 to the 2nd power. So, right? So that answer would be 2. You can type that in your calculator doing math, alpha math. All right, number 8. Log base 9 of 3. Okay, if I did math, alpha math for this and did the log base, Again, math, alpha math, and then just put your numbers in where they go. So in the little box, I will put the 9. In the big box, I'll put the 3. Now, I'm not sure it's going to let you write in your log as a decimal, but if it is a decimal, just math, enter it. So that one would just be 1/2. Number 9. Log base 7 of 1. Now remember, anytime this is a 1, your log is going to be a 0, right? Because think about this. What are you going to have to raise 7 to? 7 to what power is going to equal 1? Well, what are you going to have to raise anything to in order for it to equal 1? You're going to have to raise it to the 0 power, right? Anything raised to the 0 is equal to 1. So if this is a 1 right here, pretty much doesn't matter what this is. Your answer is going to be 0. Number 10 says convert to a logarithmic equation. You've got 10 to the 4th power equals 10,000. Now remember, when you are converting from exponential to log, first thing is you're going to have log. Whatever the base, right? We call this the base of the exponential expression. It's the base here, which means it's also the base of your log. So you're going to have log base 10. Then these two numbers essentially just are going to switch sides of the equal sign. So you're going to have log base 10 of 10,000 equals 4. Now, nobody's in an exponent here. So once you type log base 10, just arrow to the right to get out of your base, or maybe arrow up or something, but you don't go up into the exponent. This is just in the regular area. Equals 4. So again, that becomes the base of your log. These two numbers just switch sides of the equal sign and nobody's an exponent. Okay, same thing with number 11. You have e to the negative 3 equals t. So let's see, converting to a log. So we're going to have log. What's the base of the exponent? E. Switch sides. So the t is here equals negative 3. I think it'll take this, but what is another way to write log base e? How do we usually see that? That right there is usually just written excuse me, as ln, right? That's what log base e is. It's ln t equals negative 3. It should take either one though. All right, 12 and 13 are going to go the other way. They're going to give you the log equation and ask you to write the exponential equation. So you have log base 2 of 16 equals 4. Okay, whatever the base of your log is going to be the base of your exponential expression also, right? So this number is going to be the base of your exponent. Then remember, you're going to raise it to that power. So 2 to the 4th power is going to be equal to the number that is right here. So equals 16. So that's how you convert from log to exponent. That's going to be your base. Raise it to that power and set it equal to what you're taking the log of. Same thing on number 13.
Miss Hanson?
Yeah.
So we just have to put in like the exponent.
Yeah. Yeah. You just write it just like this. There's nothing to solve. It just wants you to get to relate how logarithms and exponents are related to each other.
Oh.
And to be able to go back and forth from one to the other.
Yeah.
Number 13, log base n of r equals negative x. So again, it doesn't matter what the numbers or letters are. If you're the base of the log, you're the base of the exponent. So you're going to have n to the negative x power equals r. Right? Number 14. Use a calculator to find the natural logarithm. So it just says ln of 31.1. Again, that is simply just putting it in your calculator and rounding it to 4 decimal places. So you have an ln button on your calculator. So just hit ln, and then in parentheses do 31.1 close, enter, round it to 4 spots. So 1, 2, 3, 4. After that 2 is a 0. So you don't need to round up. So 3.4372. Okay, so just be careful on your rounding if you have to round. All right, number 15 says, find the logarithm using the change of base formula. You have log base 9 of 19, okay? So before the calculators had that log base function, you could still find the log with the base of 9, but here's how you had to do it. You would just do log of the big number divided by log of the base number. That's going to get you the same thing as doing math alpha math with the log base. Doesn't matter which way you do it. So log 19. Now when you're typing this in, make sure you close after the 19, right? You want to stop the numerator, so close it, and then divide it by log 9, close. And then round that to 4 decimal places. So 1, 2, 3, 4. But this time, after that 0 is a 7, which means I need to round that 0 up to a 1. So I'll have 1.3401.
Miss Hanson?
Yeah.
How is it 1.3401?
Did you type that in your calculator?
Yeah.
What did you not get that?
Well, yeah, I just don't get how we're supposed to.
Oh, why it's not. Okay, so if you're rounding to 4 decimal places, that means count 4 places after your decimal. So there's 1, 2, 3, 4. Now you have to decide, does this, depending on what's after that 4th spot, that's what's going to tell you whether you need to round it up or not. If the number after that 4th spot is 5 or bigger, you're going to have to round that 0 up to a 1. So since it's a 7, that tells me I need to round that second 0 up to a 1.
Oh.
That makes sense?
Yeah. So what you're saying is that if that number is too low, I can't round it?
So since it was, so here's where I had to stop, right? That's 1, 2, 3, 4. But you always have to decide whether that last spot stays the same or rounds up. And the way you tell is you look at the one number right after it. If this number is 5 or bigger, that number goes up 1. So that's why it changed to a 1. It's just the rounding part of it. But if that number would have been a 4, then what would have happened? That would have stayed 0, right? It has to be 5 or bigger to round up. All right, number 16 says express as a sum of logarithms. You've got log base 18 of 18 times 324. So remember, what does multiplication of logs turn into? So this is going to turn into, I can write it as 2 separate logs being added together. Still have, both of them are going to have the same base. So log base 18 of the first number, which is 18. Then add that to another log base 18 of the second number. And you would leave it just like that. Just convert it to the sum of logs. Number 17 says express as a product. We've got log base P of S to the 5th. So what does that mean to turn that into a product? A product means there's going to be some multiplication somewhere, right? That's what product is. Anytime you have a log that has an exponent, remember, we're going to use this a lot when we're solving equations. That tells me I can bring that exponent down and make it whatever that number is times the log. So that's where we are just bringing that exponent down. So you have 5 times log base P of S. So just bringing that exponent down in front. Number 18. Log base D. And in parentheses, we have x to the 3rd, y to the 9th, z. So it says express as a sum or difference. So since the original part is multiply, we're going to change those into adding, right? Multiply and sum go together. So they're all going to be log base D. The first one, what is the first part of log base D? We're going to have x to the 3rd. That's the first one. Now we're going to add that to another log base D. The second part of it, which is y to the 9th. And the last one, so another plus log base D of z. Now, also, we can't leave logs with exponents. So the ones that have the exponents, we'll need to bring the exponent down and turn it into the product. So this one will turn into 3 log base D of x plus 9 log base D of y plus this one just stays the same, log base D of z. So unfortunately, this one is not multiple choice, so you are going to have to type all this in. If you miss this problem and you can tell that it's just because of how you typed it in, something went wrong typing it in, please send me an email. I don't want you to miss that one simply because it's typed in funny. Number 19, express in terms of sums and differences again, but luckily this one's multiple choice, so you won't have to type it all in. Log base b. And then we have fraction here. At top we have p squared, q to the 7th. And in the denominator we have m to the 4th, b to the 8th. So we're going to express this as sums and differences. So remember, and if you have a fraction here, that means the bottom numbers are what are being divided by. The top numbers are what are being multiplied. So these are going to, the top are going to be changed into sums. They're going to be the added ones. Since the denominator means divided by, division changed to difference or subtraction. So these are going to be subtracted. They're all going to be log base b's. So first thing I have is log base b of p squared plus log base b. The second one up top is q to the 7th. Now we're changing to minus, right? Anytime you go to the denominator, then you're going to minus. Still log base b. The first one is m to the 4th. Then another minus, because it's in the denominator, log base b of b to the 8th. Now, let's go bring down our exponents. And then we'll talk about that last one. So 2 log base b of p plus, bring down the 7, log base b of q minus, bring down the 4 log base b of m minus. Now, here on this last one, remember, anytime you have this situation where the base and what you're taking the log of right here, these two things are the same, this whole thing right here just turns into 1. So this right here is just all you have left. So you're just minus whatever that exponent was. And that only occurs when you have these two things are the same. It just turns into whatever that is. Which looks like D in the multiple choice. All right, I'm hustling. Number 20. Simplify the expression. ln x squared plus 12x plus 27 minus ln x plus 9. So what can you do to simplify this? The first thing I'm going to do is turn it into 1 log or 1 ln. Since it's minus, what does minus convert into when you're turning it into 1 log? The division. So I'm going to have ln. The first one will be the numerator, so x squared plus 12x plus 27 over x plus 9. Then up here, I need to factor this numerator, put it in its factors to see if I can cancel. So let's see. Factoring the numerator, x and x for x squared. Numbers that multiply to give me 27 and add to give me 12 would be plus 9 plus 3. And since I'm over x plus 9 in my denominator, the x plus 9's cancel. So I'm just left with ln of x plus 3. All right, 21. And I know I'm going fast, but watch the video and pause me whenever you need to pause me. Same thing. On number 21, we have log of x squared minus 3x minus 10. Minus log of x squared minus 4. So we're going to do the exact same thing. Since it's minus, I'm going to turn it into 1 log, with the first one being the numerator, over the second one being the denominator. Then I'm going to, this time they both need to factor. So let's look at what the top will be. X and x for x squared. This time, numbers that multiply to give me negative 10 and add to give me negative 3. Well, that's going to be a negative 5 and a positive 2, right? Multiplies to negative 10. Negative 5 plus 2 gives me negative 3. The denominator also factors on this one. And it's a difference of perfect squares, right? So x and x for x squared, and to get that minus 4, you're going to need a plus 2 minus 2. So my x plus 2's cancel now. So I have log. At top, I have x minus 5. In the bottom, x minus 2. All right, 22, 23, 24, 25 are all exponential equations where the x is in the exponent. On 22, you have 6 to the 5x equals 1,296. The first thing you want to check, because it makes it the easier kind of exponential equation solving, is whether or not this side can be rewritten as 6 to a certain power. So just check that in your calculator. I always like to just start off by raising it to the third. So 6 to the third gives me 216, which means I need to go up. So I'm either eventually going to land on 1296 or pass it. So let's try 6 to the fourth. Well, there it is, which means I can rewrite 1,296 as 6 to the fourth power. So if you can make the bases the same, like I've done here, then that means you can just set up an equation with the exponents being equal. So that would be 5x equals 4, and then solve it for x. So divide by 5. So x equals 4/5. So that is that method if your bases can be written the same. Now, what if they can't? Like on number 23. On 23, I have 3 to the x equals 10. I can't rewrite 10 with a base of 3, right? Because 3 squared is 9 and 3 to the third power is 27. So it skips it. So that is when I need my x to come out of the exponent. That's when I'm going to log both sides, right? If you do one thing, you have to do the same thing to the other. So that's why I'm logging both sides. And the reason I'm doing that is because now I can rewrite this with the x down in front of the log. So x log base 3, or not log base 3, log of 3 equals log 10. So how do I get the x by itself? I just need to divide by that log 3 to cancel it. So here's my x equals. That's calculator work. So log 10. Now remember, after you type in that 10, make sure to close it. Divided by log 3. And close it. And round your answer to 4 decimal places. So 1, 2, 3, 4. After that 9 is a 0, which means I don't need to round up the 9. So 2.0959. Right, 24. E to the negative 0.33t equals 0.51. So again, now we're solving for t, and it's up in the exponent. But remember, instead of logging both sides, when you're dealing with an e, ln both sides. After I ln both sides, that's what tells me I can bring down the exponent now. So negative 0.33t times ln e equals ln of 0.51. Now remember, anytime you see ln e, that is equal to 1, which means it essentially just goes away. So now to get this t by itself, I just need to divide by negative 0.33 to cancel it, to get the t by itself. Calculator. So ln 0.51. Make sure to close it again. Divided by negative 0.33 and round it to 4 decimal places. 1, 2, 3, 4. After the 4 is a 3, so you don't need to round up the 4. So 2.0404. Okay, I am going to keep going. I know that it is 50, so I'm going to write everybody's name down. Todd, Keys, Hines, Hauser, Bro, Peak, Barron, Ellis, Troy. Okay, I am going to keep going to get to the end, so that way this video will all be on one video. So I'm down to number 25. Six to the x equals 2 to the x plus 1. Okay, so I'm going to have to log both sides, right? Unfortunately, I can't write these as the same base. This can't be written as 2 to a power. So I'm going to have to log both sides. Now this one's a little trickier. This one brings down the x. So I have x times log 6 equals, when I bring this exponent down, it's the whole one, the whole exponent. So x plus 1 log 2, which means this log 2, the x and the 1 go to that. So let's write that all the way out. So the first, if I move the x over here, I have x log 2 plus, if I multiply log 2 times 1, well, I'm multiplying it times 1, so it still says log 2. I'm just going to drop this side down. Now, you're solving for x, okay? X is in 2 separate terms on opposite sides of the equal sign, and they're not like terms, so I can't put them together in the same basket. But I do want them on the same side as each other, Because if I put them on the same side and they each have that x, I'll be able to pull the x out as the greatest common factor, which is what I want to do. So I'm going to move this one to the left. So minus x log 2. That cancels it. Over here, I have both of them. So I've got x log 6 minus x log 2. On the right, all I have left is log 2. Now, here's the reason I did it. Now, both of these terms have an x. That's what's in common. So I'm going to pull that x out and put in parentheses what is left. So if I took the x out of both of those, in parentheses, I will have log 6 minus log 2. Over here, I still have log 2. So now there's the x I'm trying to get by itself. I just need to get rid of this, so I will just divide by it on both sides. Log 6 minus log 2. That gets rid of that. There's your x all by itself. So when I do this in my calculator, you need to be very careful when you're putting in the denominator. Since the denominator has two terms, you're going to want to put an open parenthesis in front of it. Now remember, when you type in logs, it automatically puts an open parenthesis and then you have to close it. It's going to do the same thing here. You're going to have an open parenthesis, so you'll have to close out the parenthesis for the log, and then remember, another closed parenthesis to close out the whole denominator. So when you type it in, so up top you'll have log 2, so just your regular log button, then your 2. Now remember, it automatically gives you an open, so you need to close it. Then divided by. Now here's where I'm saying you need to go ahead. You're about to say, I'm about to put a whole bunch of stuff in my denominator, but I want it all to be contained in the denominator. So open your parentheses, then do log 6. So your regular log button, 6. Now remember, it gives you an open around the 6, so you got to close it. Minus log 2. So minus log 2. Again, it gave me an open around the 2, so I've got to close it. Now I also need another closed parenthesis to close out this open right here. So you need 2 closed parentheses there, and then hit enter and round it to 4 decimals. 1, 2, 3, 4. Since that's a 2, you don't need to round up to 9, so 0.6309. All right, the next couple problems aren't too bad, or as bad. Number 26. This one is a log problem. So I've got log base 2 of 2x minus 6 equals 4. So anytime yours starts out as a log and it's just got this one log, you're going to change it into an exponential equation, right? Because I can turn this and say, well, this also says 2 to the 4th power is equal to whatever you're taking the log of, which is 2x minus 6. These two equations say the same thing, right? We can go back and forth between logs and exponents depending on what we need to get the x by itself. Well, now I can say, well, 2 to the 4th power is 16 equals 2x minus 6, and then just get that x by itself. So add the 6 to both sides. So 16 and 6 is 22 equals 2x. Divide by 2. So x equals equals 11. $27. Log base 5 of b plus 16 minus log base 5 of b plus 7 equals log base 5 of b. All right, a lot of logs. Now remember, if you have two logs on one side, here's my equal sign. I've got these two logs. They're both base 5, which means I'll be able to turn them into one log. It just depends on what this is, what that one log will be. What does minus turn into? Division. So I'll have log base 5 of b plus 16 over b plus 7 equals log base 5 of b. Now I can use the rule, well, I have log base 5 on both sides. Remember, I can do anything in the world I want to an equation as long as I do it to both sides. So I'm just going to divide that off. Divide off the log base 5. If I do it there, I have to do it here. So it just cancels it off of both sides. So now let's see what I have left. Over here, I have b plus 16 over b plus 7 equals, all I have left on the right is a b. So anytime you have a problem that looks like this, you can think of this b as being over 1 and then use cross multiplication to solve. So let's see, I'll go this way first. So let's see, this b times both of these. So b times b gives me b squared plus b times 7 is 7b equals, do the 1 to both of those. Well, multiplying these times 1 doesn't change them, so I have b plus 16 squared. Remember, you're solving for b, just like always. If it's squared, that means it's quad. So I need to set everything to one side, and then I can use my quad. So minus b minus 16 to set it equal to 0. So on the left, I've got b squared. 7b minus b is plus 6b minus 16. Put that in your quad. When you put that in quad, it's for A, B, and C would be 1, 6, and negative 16. You would get negative 8 and 2. Now, remember when you get that negative answer, remember this number right here cannot be a negative. So that's why negative 8 does not work. So your only answer is 2. Whew. 28. And remember, there is no time limit on this test. Log base 5, x plus 12. Plus log base 5, x minus 12. Equals 2. Okay, first things first, here's my equal sign. I've got 2 log base 5s on one side of that equal, so I'm going to turn those into 1. And remember, it totally depends on what this sign is what you're turning it into. Since it's plus, that means this time it's going to turn into multiplying those together. So I'll have log base 5 of x plus 12, x minus 12 equals 2. If I multiply these together, log base 5. Let's see, if I FOIL this, x and x gives me x squared. I'm going to kind of skip a step because what does your outer give you? Negative 12x. Your inner gives you positive 12x. So those are just going to cancel each other out, right? Because you had a minus 12x on the outside and a plus 12x on the inside. Then my last positive 12 times negative 12 is negative 144 equals 2. Now on this one, I don't have logs on both sides to be able to cancel them off. So if you still have a log, that's when you're going to turn it into the exponent. So 5 to the second power equals x squared minus 144. So it's quad again since your x is squared. So let's see, that'll be 25 equals x squared minus 144. So before you can put it in quad, you got to set it equal to 0. So subtract the 25. So 0 equals x squared minus 169. Be careful when you put this in quad. Your A is 1. You don't have a B, right? There is no X, so that's a 0. Then your C is negative 169. So when you hit enter, you'll get 13 and negative 13, and you don't want to use the negative one. So 13. All right, 2 more, but the last 2 are doozies. I'm not going to do the whole thing on number 29. All right, so this is the exponential growth function, okay? And this is when things are compounded continuously, right? Instead of quarterly or biannually, that's when they're compounded continuously is when you want to use the E. So that's why this is this formula, okay? This right here is going to be your starting amount, then the E, the K is your interest rate, and the T is the number of years it's been invested. So let's see, suppose that $10,482 is invested at an interest rate of 5.8% per year, compounded continuously. So my initial amount is $10,482. My interest rate is 5.8%. And I want to turn that to a decimal, so I'll move it 2 places to the left. Fill in that blank with a 0. So 0.058 is what you're going to use for the interest rate. I don't know what the T is. So the first thing I have to do is to just come up with what P of T is using what we know. So the original amount goes in the first spot. So 10,482. E, the K is your interest rate in decimal form, so 0.058 T. So that's going to be what you're going to put in as P of T in that first spot. Now, the next 1, 2, 3, 4 spots are just changing the T to whatever the year is. So let's do, so the different ones are 1, 2, 5, and 10. Okay, I'll just do the 5 one. Again, all it is changing each time this T. So if the money has been in there 5 years, I'm finding P of 5. So 10,482 E to the 0.058 times 5. Put that in your calculator to get that answer. So 10,000, ooh, I wrote this wrong. 482 E to the 0.058 times 5, exactly like you see it. So 10,482 E. So remember where the E is. It's the LN button, but it's blue. So I do second LN to get the E. Now up in my exponent, I have 0.058 times 5. So exactly like you see it. So after 5 years, that's how much will be in there, and we are rounding to 2 decimal places. So 432, which means the 43 doesn't round up. So after 5 years, you'll have $14,008.43. Okay, so again, you'll do that a couple more times, just depending on what it tells you the T is. It's going to give you different numbers for T. The very last part of this wants to know, what is the doubling time? In other words, how fast is my money going to double? You're to find doubling time, or how fast it takes it to double, it's always the same formula. So the doubling time is always ln of 2 over whatever the rate is. So for this one, it would be ln 2 over 0.058. Put that in your calculator. So ln 2 close divided by 0.058. Round it 1 decimal. Oh, this one's kind of tricky. I don't know if yours will be like this or not. 11.9. But look after the 9. It is a 5, which means what does the 9 round up to? 10, which actually rounds 11 up to 12. That one was tricky. All right, last one. All right, this is the very last problem that we did in that last section about the percent of adults being married going down, which means I'm using this same formula, but if it's going down, I need to put a negative in front of the K. All right, this chart gives you more information than what you need. You just need to know the starting information, which was the year 1960, 74.9% of people were married. And then in 2012, which is the end of the chart, 42.2% of people were married. Okay, the first thing it wants me to do is find the K. What was the rate in which the population being married was decreasing? So let's see. Remember, this is always your ending amount. So that's my starting amount. This is the ending amount. It's lower because the percent is dropping. So my ending amount is 42.2. This is always your starting amount, which is 74.9. E to the negative, I don't know the K. Do I know the amount of time that it took to get from 74.9 to 42.2? I do. I know that it was from 1960 to 2012, which is 52 years. Solve it for K. Now this takes some work, right? This I'm eventually going to want to bring that k out of the exponent, but the first thing I want to do is get rid of that 74.9. So I'm just going to divide it off. So that goes away. There's my e. Up here I have negative k times 52. So I'm just going to write that as negative 52k. 42.2 over 74.9. Now I'm going to use the rule that brings my exponent down. And since I'm dealing with an e, I'm going to ln both sides. That's what brings the negative 52k down. Times ln of e, but remember that's just 1, so it just cancels. Over here I still have ln of 42.2 over 74.9. So it's just one step left to get that k by itself. I just need to divide it by negative 52. So that's going to be my k answer. Just type all this in your exponent. Remember, when you're doing the ln, you're going to want to put a parenthesis around the top and then divide it by negative 52. So let's try this. ln 42.2 divided by 74.9. Close it. Go ahead and enter that. And then divide this by negative 52, which gives you a k of 0.0110. So that's what's going to go in your first blank for the k. All right, the next thing says what it gives you some blanks here. So what's going to be my formula to figure out other parts? So m of t is going to be equal to the starting amount, which is 74.9, e, and then up top it has blank t. Now, there's the rate, but what needs to be in front of it since it's dropping? So I'll have negative 0.0110 there. So now that I know the k, and now I can put this in that formula, I can answer the next two questions. In 2015, what percent of adults will be married? So here's my formula. This is how fast it's dropping. I know t now. So what was the beginning times? 1960 to 2015, which is 55 years. So I just need to change that t to 55. So beginning amount, 74.9. So again, I'm using this formula and just making this t a 55. So 74.9 e to the negative 0.0110 times 55. And put that in your calculator. So 74.9. Second ln to get your e. It automatically bumps you up into the exponent. Type this exact thing in your exponent. So negative 0.0110, open parenthesis 55, close. And hit enter. Round to 1 decimal place. So there's my 1 decimal. After the 9 is a 0, so I don't need to round it up. So it's going to be 40.9. Then it wants you to do it again for 2018. I'm not going to do it again. That just means now what is the t going to be? It'll be 58. So you're going to do the exact same thing, but it's 58 years this time. All right, last part of it. At this decay rate, in which year will the percent of adults who are married be 30%? So it wants to know when this number will be 30. So I have my formula is M of t equals 74.9 e to the negative 0.0110t. Okay, but now it's saying when will this number be 30, right? When will it be 30% married? So, what all do I know? I do not know. I'm trying to find this year. So I don't know the T. I do know the beginning amount and the end amount. Where does that end amount number go? Always right here. That's where your end amount goes. That's the number I'm looking for, is that T. It's up in the exponent, which means in a minute I'm going to have to ln both sides. But before that, get rid of the 74.9. So I've got e to the negative 0.0110t equals 30 over 74.9. Now ln both sides. That'll bring down your exponent. So I've got negative 0.0110t ln e, which remember just cancels, equals this. So ln of 30 over 74.9. So I'm getting the t by itself. So divide by negative 0.0110. That'll give you your t. Let's put this in our calculator. So ln 30 divided by 74.9. Now remember, after you type that in, close it to close out your numerator. Then divide that, or go ahead and hit enter, and then divide that by negative, oh, I typed this, that's not where the decimal is. Negative 0.0110, enter. So let's see, it says to round it to the nearest whole number. So since it's 83.1, it's going to be 83. Now, be careful when you type in this answer, because what is this telling me? That's the number of years after the starting time. The answer wants to know, what is that year? Well, if the starting time was 1960, and it took me 83 years to get to that 30% married, I need to add the 1960 to this. So the year would be 2043. All right, I'm sorry. I know that was forever long, but I wanted to get it all in one video so that if you wanted to watch it again, it'll all be together in one YouTube.